I'll be addressing
Okay.
your questions, whatever you type in the chat box.
Okay, so I already saw some direct message questions. Hello, sir. Are all the
Okay.
satellites interconnected with each other with country to country? There's one question. Um, so no, they're not. So normally when we, for example, as TU Berlin launch a satellite, then we have our own 3, 4 ground stations, and we are only using our ground stations to connect with our satellites. But of course, you can have any agreement with any other company or university or ground station network provider that can support you in getting the data from your satellite. Then there was another question that was nice. I'm 15 years old, so would you think that I'll be able to build a satellite? So for sure. I mean, you're on a path to starting your career at some point. Your education, your lifelong education, and your career, and and of course, in the long term, learning about it is definitely an option. But I'm going to be honest. Nowadays, there's a movement towards even smaller satellites. There's a femto satellite that is just this
Right.
size, and you have a microcontroller on top, a small solar cell, and just maybe a small sensor, and this is something that I strongly believe in. A 15-year-old person can build, and that can be potentially sent to space. And I normally I'm juror in different I'm jury member of some competitions where students take part and build rovers with Lego and stuff, and they're able to program microcontrollers. I've seen 12-year-old people who build small systems, so there's definitely possible. So which book is the best to get the maximum knowledge in the field? So my recommendation is to start with maybe a general book that gives you an overview. For example, the Handbook of Space Technology or the International Handbook of Space Technology. That's more that's the US version kind of. That gives you a broad overview of all the different topics in space technologies. And then, of course, you can, for any subsystem, for any mission aspect, there are several different books. Like one of the, I'd say, Bibles in our industry is Space Mission Analysis and Design, SMAD for short, as an abbreviation. But I'd say that's a bit more on the advanced side, because that already guides you through designing or doing preliminary design for all the different systems in a satellite.
So there is a question here asking how to set up the scientific goals for student set.
That's a good question. Yeah. So how to set up the scientific goals? So first, you need to know what satellites do. Like you can browse in the internet. You can read literature, and lay out a map for yourself, saying that satellites have different purposes, and figure out like what are the different purposes of a satellite. So I have some backup slides, for example, that are conveniently just in that direction, because I always expect similar questions, and those are the main 4 areas of space utilization. So observation of the Earth. So, for example, how do we detect climate change? We measure the Earth's atmosphere, and then for measuring the Earth's atmosphere, there are several parameters, several instruments that you can use to measure the Earth's atmosphere. To take pictures and different colors, and you have communication navigation services that you use every day. You have exploration of space, where you do science. So there are several areas, and also several commercial areas that you can think about and first need to understand before you can come up with your own idea. And then maybe you'll find something that fascinates you, and you say, you know what, I think there's a gap. We can do something in that region.
So the next would be what software is most preferred or the simpler one. So I assume that he must be asking for a software to design.
Okay, software. There's a lot of software that you need in a satellite mission. So You need software for, of course, designing your mechanical model. So anything CATIA, SolidWorks, whatever you use, you need electric software to design your electrical models, the circuit board designer. You need software for the thermal model simulation. So a thermal node model that you need to set up, or you may even go as far and to develop FEM models for mechanical and thermal considerations. So there's a lot on that side. There's software for the satellite itself. So you need to develop the onboard software. So you can do that in any software that you're familiar with. Mostly it's done in C, C#, C++. Then you need software like for mission control. You can either have a custom-made software. You can download like an open source version and modify it to your needs. You can get a commercial version. You need software to analyze the mission. So there's the satellite toolkit, SDK, there is GMAT from NASA. They're all on a different level of sophistication. So there are lots of software suites that you need. Yes, and I can't say which one's the best for each area. Probably I can give some recommendations.
It's based on the application that we are talking about, right? So it depends on what application are we targeting.
So that's what I talked about was mostly for the satellite bus. So independent of the payload itself, so to develop the bus to run the mission, and then depending on the payload itself, of course, you still need, other software. If you take pictures of Earth, you want to connect them to a database, maybe a commercial database, a public database. Then you need that interface. But if you do communications, it's a whole nother story. So you may need other software in the background.
All right. So the next is, can small satellites be used in deep space missions?
Yes, of course, you can use them for deep space missions. But the radiation environment, especially the radiation and the thermal environment change, and can be harsher than the low Earth orbit. So that's why you need to improve the reliability of your system. But of course, yes, you could send a CubeSat deep space. That's surely possible.
Then I want to become an astronaut. What should I study? My interest lies in mechanical. So how do I pursue it? That is the question.
Okay. So if you want to become an astronaut, then what do I need to study? So they take different people from different backgrounds. So you don't have to have a specific background, but some backgrounds are preferred. Of course, some astronauts have a background of being a pilot. Of course, you need to steer that ship. But then others are from a research background. They maybe they're biologists. They're from medicine, and they're trained in other aspects as well. But their main purpose is more science related. So you don't necessarily have to be a space engineer. So a space engineer is not the main purpose is not to become an astronaut. So if you want to participate in any campaign, I don't know if there's in Europe. I know in Europe that every almost decade there's a call for new astronauts, and then there's a whole selection process. I actually gave a lecture about that in the master's program, and then I did a small astronaut test with the students just to give them an idea what they need. They need very good people skills. They need very good leadership skills and communication skills. So there are many different aspects. So it's not so much about your age, and you don't have to be super healthy as kind of people think. You need to be super healthy as
the popular belief.
Yeah, so that's not really true. So of course you need to be healthy in general, and then you need to be super lucky. So you need to see that call, you need to apply, you need to compete with tens of thousands of people who apply too, and then you may make it in the end.
All right. So the next is, sir, provided we do the design and architecture of satellite, I find launching a much bigger challenge due to the limitations within student community. So how this could be resolved?
Okay, so if I understand the question correctly, so you're saying yes, you can imagine to build a satellite, to go through all the different challenges, but to finally come up with the satellite. And then you need to launch it. So of course, you won't build your own launcher to launch it. So basically, you buy a launch slot, and and there the main thing is you need that money, that amount of money to transport your satellite into space. Let's say you have that money, then this is no problem at all. You just put your satellite in the in the deployer, and then it's ejected in space. No issue at all. That's one of the easier parts actually of the whole mission. But from your satellite engineer perspective, but how do you get the funds? That's the big question. So of course you can't afford that, as most universities, they won't be able to afford the whole launch for, even if it's just a 1 kilogram CubeSat. It's too much money. So in our case, we get money from the government, so from through the German Aerospace Center. So and in India it will, I don't know, Israel probably may provide some opportunities for students to send their satellites to space.
There are several instances though where the students of several IITs have joined hands with ISRO, and they have sent their payloads, their small satellites into space.
Oh, okay.
But there are very limited opportunities as we speak, but they are expanding the horizon. So that is a good thing.
Thank you.
So the next is, what are the major reasons for the satellite mission that could not be successful?
Ooh, there's a lot. There are whole papers about this topic. So what are the main reasons? So of course you can have a deployment failure. So let's say your satellite is ejected, but it doesn't even turn on in the first place, or somehow your turn on mechanism doesn't work. Your batteries don't charge properly. So there are failures like that. Sometimes it may be the communication. So maybe your antennas don't eject properly, and your bandwidth, like your power, is not calculated properly. Things are misaligned. You basically just lose contact. Radiation is over time at least an issue. I mean, small particles are hitting your satellite the whole time, hitting your electronics, because they're not protected by the atmosphere anymore, and that can cause errors in your satellite, either bit flips where your satellite software is affected and is kind of stuck. If you don't act on it, then your satellite is going to be stuck, or it can even damage the electronics of your satellites. So there's several reasons. So there's a whole list of reasons. Very often it's not even known. I mean, let's say you send your satellite up there and you don't know, you don't have contact. So it's very hard to analyze the main reason.
Even the failure of a single component can get the whole mission to dust.
Of course, definitely, yeah.
Right. So the next is, sir, what kind of satellites are used for educational field?
Very often it's, I think most are technology demonstration satellites. So those are really universities who want to show that they can build a small satellite in the first place. And then after that, I'd say it's, I'm not actually sure about the whole percentage of, but you have Earth observation. So you have several instruments like here, CubeSats taking pictures of, or small satellites taking pictures of Earth. Let's take, for example, I have another slide with different small satellite constellations. So this is a trend, mega constellations right now, where several providers like SpaceX with Starlink, or Amazon with Project Kuiper, and OneWeb from Airbus want to provide internet through space. So many places around Earth don't have access to internet. And actually most of the globe doesn't have access to internet. And space would allow that. So if you have a constellation of thousands of satellites that communicate with each other constantly, and you just have a small station on ground that connects with the satellites, then that's a really great case, a business and use case. Another case is, for example, Planet Labs. They have their small satellite constellation of 3-unit CubeSats, and then they take one picture of the Earth per day, the full Earth, one picture of the whole globe once per day. And just imagine what you can do with that data. You have a whole database and you can take a look at Earth every single day, the whole planet. And that's great for agriculture, for civil engineering, and many other areas. So those are use cases. And small satellites, the university CubeSats, they try to contribute to those bigger visions by, for example, sending small sensors, communication equipment to space and testing it in a way to say, okay, this is improved new technology. This could be utilized in another of the bigger visions. So that's what you often do.
All right. So we'll take some quick questions now to end this session in the coming time. So there is a question that can we reuse satellites just like we have developed the technology to reuse the rockets?
Thank you. That is so you have to think about it. You send your satellite up there, then how do you get it back? That means you have to get back through the atmosphere. So you have to use either fuel of the satellite to get back, or you have to send something to grab the satellite and bring it back. It can't burn in the atmosphere. It will go through a lot of stress, and after its lifetime, it will be in many parts used anyway. And then refurbishing it and sending it up there is not going to be economical or ecological. So satellites need to be removed after their lifetime, because otherwise space gets too crowded. Low Earth orbiting satellites are burnt in the atmosphere, normally within 25 years. And geostationary satellites, geosynchronous satellites, they're pushed back to a graveyard orbit where they normally don't harm other satellites. So they just idle there. But no, there's no vision of reusing satellites because there's no practical use for that yet.
So one question related to TU and yourself is, sir, is there any way one can do a project with you or in TU?
So I mean, at TU Berlin, we have lots of students, of course, in our different programs. We have a German aerospace study program. We have an international master's program. And of course, all the lecturers and the staff is occupied with the project with the students. So it's, and then those students are looking for thesis and for jobs in the environment. So I will honestly say that it's going to be very difficult or almost impossible to do a project from outside at the university if you don't have a real affiliation. Like if you're not a student at the university, and if you want to do a project at the university or at the regional in any of the regional companies, because it's already a space hub here in Berlin with lots of students. So it's going to be difficult, but of course there's things like the university offers summer programs, either on site or online, and in that scope, of course, the university charges for that, but in that scope, it's possible to do projects. Yeah.
So I have a question personally, because
Yes.
I conduct my own research in the field of electromagnetic propulsion. So since the study of electric propulsion is related right now as we speak, because we cannot produce a lot of thrust, but an efficient specific impulse. So it is used for station keeping or either orbit maneuvering or maybe attitude control. So how often is it the case when electric propulsion is used, and why not in all the satellites? I understand one point that for just a jump from parking orbit to the destination orbit, where chemical propulsion can take you within a couple of days, electric propulsion may take a couple of months. So that is a limitation, I understand. But what is your view on that?
Okay. So yeah, that depends on the needs, the requirements of the mission, what type of propulsion system you actually apply. So of course, with chemical propulsion like monopropellant, bipropellant, or even solid propulsion, you have a very high thrust. but you only have seconds or minutes that you can actually use it until you lose all the fuel, basically. So that is what are the purposes here. So you have maybe an apogee kick motor. So your satellite is transported with the rocket to low Earth orbit, and then you're transported back to higher to a geosynchronous orbit. So the satellite does that by itself. So you use that bigger chemical motor. It's faster. It's more economic. And then, as you said yourself, for long-term station keeping, or then it may be useful to use electric propulsion. You have more efficiency. You need a smaller amount of mass, tank size, but of course, yeah, you need some patience, because you have a high specific impulse, but you have very low thrust in the millinewton range, basically. And you need it for certain things, just like you said, for some station keeping. You can use it for attitude control. So I would of course prefer, and nowadays the most modern satellites, like geosynchronous telecommunication satellites, they have really cool concepts, like the Eurostar series from Airbus. They have a robotic arm with an electric propulsion system. So that robotic arm is able to just steer the satellite and the thruster. Very interesting concept. So this is more this is more ecological also, to have an electric propulsion system. It's more lightweight. So I clearly see lots of benefits. But normally in a satellite you have at least two, sometimes three, in very few cases even more different propulsion systems. So you have the chemical propulsion system that has a certain purpose,
Right.
and then you have the electric propulsion that has another purpose.
Right. Okay. So I must say we are overwhelmed with the questions here, but I understand the time restriction that you also have. So I'll just wind up with the final question that one of the student here has asked, and that too is in my mind. What is your final message to the student generation, to the community of students who are trying to, develop their career into space sector in any way?
In any way. So yeah, if you want to join the space movement, then I really encourage you to do so. In as any type of engineer, even if you're not an engineer. So I'm happy to share the slides that I have here, and I will tell you that, for example, if you look at the global space economy, then the actual satellite manufacturing and the launcher industry is the smaller part, actually building the satellite. The the bigger things happen in the downstream industry. Like, what do you do with all that data from space? What science do you do? What business do you build? So even if you're not an engineer, think about all the business around it. What can you do with satellites? How can you utilize them? And you will find extremely many funding opportunities. So if you have one tiny good idea, and you pitch it, then you can create really something innovative, and anyone can do that. I know students who sat down and just try to think about an idea and then pitched it to a competition, and then they went to the next competition, they got some funding, and now they have companies with 20, 30, 40 employees. So just I encourage you to do that. Sit down and do that. And then there are different career options for joining the space industry. So there are engineers, technicians, science people, administrators, that can have a role in that industry. So the least amount of engineers are systems engineers in the aerospace industry. So you need electrical, software, mechanical engineers. You don't need a space engineering degree to join a space company. They need all the others too. And if you have some additional education on the side, if you visit a course, if you read a lot about that topic, if you get any kind of certificate, whatever, to get that additional knowledge, to understand the requirements as an electrical engineer for the space environment, for that industry, then that's great. So my message is, if you want to join the space movement, then just do it. Whatever you are, wherever you come from.
All right. So thank you very much. On that note, I must say that we'll end this session here. It has been a pleasure to bring you on board. And thank you very much again for spending a precious amount of time with us. It has
Of
been
course,
really interesting and a very helpful journey, I'll say.
wonderful. Yeah, thank you very much. I'm very happy that that you invited me, and it's an honor and a pleasure to have been here. And I'm sorry that I wasn't able to answer all the questions. There a lot more in the chat, but of course, just feel free to contact me. You can just connect to me on LinkedIn, and so feel free to do that. Yes, and it was a pleasure. Have a great evening, and then looking forward to see you soon someday.
Okay. Thank you very much. Have a good day.
Bye bye.